Hello everyone. So today we'll be solving this lead code problem, minimal total distance travel, which is a lead code problem 2463, and which is a hard problem. So let's first understand what the problem is saying. The problem is saying that we have been given an array of robots with their positions and an array of factories with their position and limits, and we have to tell the minimum distance a robot need to travel to the nearest factory to get fixed. So let's say we have given robots with position as 1, 5 and 9, and we have given factories with position as 2, 1, that is factories at position number 2 with limit 1, and 6, 2, that is factory is at position 6 with limit 2. Then we have to travel the minimum distance. These three robots need to travel to these factories to get fixed. So if we visualize this problem, then we have an x-axis here. So let's do an x-axis with 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have a robot at position number 9. We have a robot at position number 5 here, and we have a robot at position number 1st here. We have factory at position number 2 with limit 1, so I have a factory here, and I have a factory at position number 6 with limit 2. So I have a factory here with limit 2, but I can also say that instead of one factory with limit 2, I have two factories at position number 6 with each have one limit each. So to simplify this problem, I can say that the factory at position number 6, there are two factories with limit 1, 1 at position number 6. So now the minimum distance these three robots need to travel to get fixed at factories will be the robot at position number 9 need to be traveling to the nearest factory, that is at position number 6, to get fixed. So the answer is going to be 9 minus 6 equal 3. The robot at position number 5 need to be traveling at factory at position number 6, so the answer for 5 is going to be 5 minus 6 mod equal 1. And the robot at position number 1 need to be traveling to the nearest factory position number 2, because these factories have already fixed these robots 5 and 9. So the only option for robot number 1 is this factory at 2. So the robot number 1 needs to be traveling at factory at position number 2 with to get an answer 1. So the total answer for this problem is going to be 3 plus 1 plus 1 equal 5. So how we are going to solve this problem? From how we are going to solve this problem? In order to solve this problem, we can take a DP array, and before we take DP array, let's first try to understand what we are trying to solve. So I will be referring this ebook here, Dynamic Programming One Shot, and in this ebook there is on part 2 of this ebook at page number 1 we have something to tackle this problem. So before starting every DP problem, we have to ask these 4 questions from ourselves. What changes? So let's get back to the problem and see what is being changing. I'm writing first question that we need to ask from ourselves, what changes. So from the problem it is clear that there are two things that are changing. First thing is the robot position, and the second thing is the limit of factories. Initially the factory at position number 6 had limit 2, then it fixed one robot, then the limit has become 1, then again another robot, the limit has become 2. So there are two things that are being changed: robot position and limit of factories. The next question that we need to ask from ourselves is, what choices do I have? So let's write choices. What choices we have in this problem? So for each robot, the first choice is obviously, for each robot and each factory, the first choice is assign. That is, I can assign the current robot to the current factory. So for a robot at position 9 and position at factory at position number 6, I can have a choice that is assign, that I can assign the robot at 9 position of the factory at 6 to get an answer. And the second choice is skip. that I do not want to assign the current robot to the current factory. In that case, I'll be borrowing my answer from a future state, and we will see how we are going to do that. The next question, what is being asked? That's right. What is the question asking from ourselves? Question is asking the minimum distance each robot need to travel. So we have to minimize something here. And what is, we have to minimize the distance. That is the difference between the distance of robot and factories. We have to minimize that variable. And the next question we need to ask from ourselves is where the answer is stored. How we are going to store this answer? So let's write store. So to answer this question, first we have to look at the question number one, that is what is being changing. So there are two things that are being changed. So it's obvious that we have to take a 2D array to store these two variables. That is, we have to create a 2D array. We have to create a table of dp. And since we have a choice as skip, in that case we will be borrowing answer from future. So and so it's obvious the we so it's obvious that we have to store the answer at position number 00 here in this cell, that is dp00. And why we have to store in dp00 and not in dp m minus 1 or n minus 1, we will be I will be coming back to that part later in this question, why we are not storing the answer is here. As we will proceeding with the question, it will become obvious that why we were not storing the answer in dp m minus 1 and n minus 1. And one of the reason for that is we are going to borrow the state from the future and not from the past. And let's see how we are going to do that. So as I told you earlier that instead of writing a single factor at position number 6 with limit 2, we can write two factories with limit 1 1 at position number 6. What that mean is I can break this 2D array into a single array of factories, and I can say the first factory of my is at position number 2, the second factory is at position number 6, and the third factory is position number 6. So I can flatten this 2D array into a 1D array to simplify my problem, and it will become easier for me to fill this dp array now. And what dp pattern we are going to use here, if I refer to the ebook again, so from the ebook there are, when there are two situations in the problem, two strings in the problem, then it's obvious that we took the two sequence string dp here. So the pattern matches this state here, and you can read this from the ebook. I'll be sharing the link to this ebook in my comment section, or you can buy this ebook from here. You can head over to himanshusaini.com and you can purchase this ebook, dynamic programming in one shot, to solve any kind of question in dynamic programming. It is a very short and quick ebook to refer any dynamic programming question. So let's coming back to the problem again. So okay, we have flattened these factories, we have robots, and we have choices assign and skip. So let's try to write our recurrence relation here. Okay, so for the recurrence relation, my assign is going to become, that is for dp, for the state I and j, for the state I and j, my, since we are taking the absolute value of factories, position of robots and position of factories, so if I assign the robot I with at factories j, then my answer is going to be math.abs I minus j plus the answer from the future, that is dp of I plus 1 and j plus 1. And if I skip my current element, that is I am not going to assign my robot at position I to the factory at position j, in that case I will be going to borrow the answer from the future. That is, for skip the dpi, I will borrowing the answer from the for robot I from the factory of j plus 1. That is, for the current robot, I will going to borrow my answer from the future factory, that is j plus 1, if I'm not going to assign the robot at position I to the factory at position j. And we have to minimize this distance, so my final answer for dpij is going to be, it is going to be math dot minimum of assign and skip. Assign, skip. I will be also sharing the link to the solution to this problem in the description of this video, so you can refer to the solution directly in the from the link in the description. So let's start solving this problem now. Okay, first thing we have to do this in this problem is that we have to sort the robots according to their position and also the factories according to their position as well. So the first thing we are going to do is sort. I'm going to use collections.sort to sort the robot list, and I'm going to arrays.sort to sort the factory according to the first element of the factory, that is position of the factory. So I will be using a comparator operator here. Comparator is comparing int f0. So in my comparator is going to sort this array of factory according to the position of the factories. The next thing I need is I have to flatten this factory into a from 2D array into 1D array, as I have told you here. So for that I'll be taking a list of integer named factory positions equal new array list, and next thing I have to sort. So for that, and in order to sort, I can take what I can do, I can iterate over the array inside this factory, and then again I can iterate over in this array and fill the position here, that is 2. For 2 6s I can fill 6 twice, so I will writing this code here now. So for int array of f inside factory, for int I equals 0, I smaller than factory, sorry, not factory, f first, and I plus plus, I will be adding to the factory positions the position of the factory f0. How many times? f1 times. Factory position dot add. Okay. Now next thing we have to build our dp table. So for that I'll be taking the robot size, int robot size equal robot dot size. I will be taking factory size. Factory size is going to be the size of these factory positions, factory position dot size. Now I will build my dp array, long dp equal new long. I will building a dp array of one extra size here, robot size plus 1, with one extra row and one extra column, factory size 1 plus 1. And the first thing we are going to fill in this dp table is our base states, or the impossible states that are impossible to reach. So for the, and what are those tables? So if the dp array is this of for this particular example, the size is 3 3, so I will be taking a dp array of size 4 4. So let's create an table with the rows 4 and column 4. 1 2 3, so there are 4 columns now. 1 2 3. Let's write the robots here, 1 0 1 2 and 3, and the factories here 0 1 2 and 3. So what are the impossible states? So a robot can never be fixed at the robot 0 can never be fixed factory at position number 3, because there are no factory at position number 3. What that means is what will happen when there is a robot and there is no factory left? In that case, the robot can never going to be fixed. And to write the state in this cell, I'm going to write infinity here. Infinity for robot 0 at factory number 3, infinity for robot at position number 4, for first robot at factory at no factory, that is in uh, for no factory left. The second robot, when there are no factory left, the answer is going to be infinity obviously, and when there are no robots left, no factory left, the my answer is going to be 0. So I have to fill this base state in my code. So to fill that base state, I'm going to write for int I equal 0, I smaller than robot size I plus plus, dp of I, and the case when there are no factories left, factory size, my answer is going to be infinity. So I'll be writing a very long number here, 1 raised to the power of 12 to represent infinity here, and I have filled this dp now. One thing to notice that this cell is still 0, this cell is 0, and these cells are also 0, these are base state. We have filled the third row and third column as our base case. Now we can start filling our dp array, our dp table further, because now our future states are defined here perfectly. So I will be starting from the last cell, that is for int I equal robot size minus 1, I is greater than equal to 0, and I minus minus, for int j equal factory positions minus 1, j is greater than equal to 0, and j minus minus. I am at the last cell of my dp table. To fill the last cell, I have two choices here. And what are those two choices? That is, assign the second robot to the second factory. This cell tells that either I can assign my second robot to the second factory, or I'm not going to assign my second robot to the second factory. In that case, I'm going to borrow the answer from the future. So for int I equal to and j equal to, my assign variable effectively become, for int I equal to and j equal to, my assign variable effectively become that I am going to assign my robot at position second to the my second robot, I'm going to assign the second robot at position 9 to the second factor at position 6, and my assign becomes math dot absolute position of second robot, that is 9, minus position of second factor, that is 6, plus what was the value traveling from the future, that is dp of I plus 1 j plus 1. So here the answer is 9 minus 6 3, and the dp of I plus 1 j plus 1 is dp of 3 3, and 3 3, when there are no robots left, no factor left, the answer was 0. So assign becomes 0, and what will happen if I do not assign, that is I skip, I'm not going to assign my robot at position 9 to the factory at position number 6. In that case, I will answering my I'll borrowing my answer from the future, that is when there were no factors left. So my skip becomes dp of I, and for the factory j plus 1, so dp of 2 for the factory 3, and the answer in that case was infinity. So my skip becomes infinity, and I'm going to take the minimum from both. The minimum is 3, so for this cell the answer is going to be 3. Similarly, what will happen for I equal to j equal 1, either I'm going, the first variable is assigned, that I assign my second robot to the first factory, the position of second robot was 9, and the position of first factory was 6. So the math.abs become 9 minus 6, and plus I plus 1 is 3, j plus 1 is 2, so 3 plus 2, 3 3 2. Third row and second column, the answer was, for third row and second column, the answer was 0. So assign it becomes 3 here, and what the skip becomes j j2 i2, j2 and i2, 3 3. So skip is also 3. What that means is, the for the second robot, that is 9, if I assign the second robot to this factory, then the answer is 3. And if I skip, I do not assign my robot 9 to the second factory, in that case I will borrowing the answer when I assign the robot my 9 to the third factory here. And when I assign the robot 9 to the third factory, the answer was 3. So the skip is also 3. And what is the minimum of both? The minimum is 3. So I will be writing 3 here. Next case, for I equal to j equals 0, either I can assign my second robot to the 0th factory. In that case, the answer is going to be the position of the second robot 9, and the position of the first factory 2, 9 minus 2, plus the answer traveling from future for the uh, I plus 1 and j plus 1, that is 3 and 1. For 3 and 1, the answer was 0. So the here answer becomes 7. And if I skip, I do not assign my third robot to the 0th factory. In that case, I will borrowing the answer for third robot for the second factory. That is, what was the answer when I assigned my third robot to the 6th factory? That is the answer for dp I and j plus 1, that is the dp2 I2 and j1. For I2 and j1, the answer was 3. So skip becomes 3. And what is the minimum from both 7 and 3? It's 3. So I will writing the answer 3 here. Now coming to the second row, I equal 1 and j equal 2. What if I assign my first robot, that is at the position number 5, to the third factory at position number 6? If I assign my first robot to the second factory, then the 5 minus 6 is 1. The abs of 5 minus 6 is 1, plus the answer for 2 and 3, I2 and j3, 2 and 3, it's infinity. So assign answer becomes infinity. And why it is infinity? Because the third factory is already assigned to the robot at to the third robot at position number 9 in this row here. So the answer for the second robot, if we try to assign the second robot to the third factory, is infinity. That it means we are never going to be able to assign the second robot to the third factory, because the third factory is already assigned to the third robot here at position number 9. And what the skip becomes here? Skip is also I2 j3, I2 and j3 is infinity. So infinity, minimum infinity is also infinity. So I wrote infinity here. Let's move to the first factory for I1 j1, that is second factory and second robot. For if I assign my second factor to the second robot, if I assign my second robot to the second factory, then it's become 5 minus 6 plus answer at 2 2. The answer at 2 2 is 3. That is the answer for this. And the answer when the second robot was sent to the second factory, then the answer was 3. And total of these answers are 4. And if I skip, that is I do not assign my second robot to the second factory, in that case I will borrowing the answer when the robot was assigned, the second robot was assigned to the third factory, and in that case the answer was infinity. So infinity, and the minimum of both is 4. So I'll be writing 4 here. Similarly, if I go and fill all the dp table for I equal 1 j equals 0, then it becomes second robot 5 minus 2 4, sorry 5 minus 2 3, plus answer for 2 and 1, answer for 2 and 1, it's 3. So 3 plus 3 is 6 here. If I skip, I do not assign, then the answer becomes for dp for this is I and 1 1 1 and 1, and the answer is 4, and the minimum among both is 4. So I'll be writing 4 here. Similarly, if I try to assign my first robot to the second factory, it's going to be infinity here, because the second factor is already assigned to the third, because the third factory is already assigned to the third robot. If I try to assign the second robot to the second factory, the answer is also infinite, because the second factory is assigned to the second robot here. And let's see what is the answer going to become for dp00. So that is our final answer. So if I try to write dp00, it for that the assign is going to be, if I assign my 0th robot to the 0th factory, that is the difference of these two, 1 minus 2, 1 minus 2 plus total answer so far from the future, that is 2 2, sorry 1 1, 1 and 1 is 4, so the answer is 5 here. And if I skip, that is I do not assign my first robot to the first factory, in that case I was borrowing the answer for the first robot from the second factory, and the answer was infinity here, and the minimum both is 5. So my final answer for this question is 5 here. And now let's try and complete our code. So first thing is, I assign my current robot to the current factory. In that case, the answer is going to mat.abs of robot.get I minus factory positions dot get j. Plus answer from the future, dp I plus 1 and dp of j plus 1. ASSIGN assign. And if I skip, then I will borrowing the answer for the current robot from the future factory, that is dp of I, and when it was assigned to the factory at j plus 1, and will borrow answer from here. And I will fill in dp ijs minimum of both math dot min assign and skip. And in the final, so I'm going to return the answer from dp of 0 and 0. And let's try to run this code. Okay, I have a mistake here. Okay, here it should be factory size and factory positions. Let's try again. Okay, it has passed the initial cases. Let's try to submit this solution. Okay, the solution is accepted, and I hope you have understood this question. And to refer more dynamic problem in future, you can refer this ebook, Dynamic Programming in One Shot. The link to this ebook is given in my bio, and you can also buy this ebook from himanshusaini.com. Thanks, goodbye, have a nice day.